Okay, we're going to do some more modeling with quadratics just because I think it's pretty tough because it's combining everything we've learned and reading word problems, which nobody likes. So we are going to model and solve problems with quadratics again. Alright, so here's the quadratic regression. We've talked about this. This is how you do it in the TI-84 calculator. You can pause the video and write this down, but you should have already learned how to do it. Alright, so either using Desmos or using the TI-84, I want you to go ahead and find the equation of best fit. So when we talk about x, we are talking about time in seconds. And when we talk about y, we're talking about the height of the amusement park ride. Alright, so go ahead and put that in your calculators and come up with the equation, the curve of best fit, sorry. So pause the video in 1, 2, 3. So here's what I got. Hopefully you got the same thing. Okay, and then I'm going to read part B to figure out what I'm doing. So how many seconds, x, will it take the tower to reach the ground? And if you were on the ground, you were at a height of 0. I think the easiest thing to do, graph this in Desmos. So you're going to get a tower, and you just want to figure out where does it actually hit the x-axis. So how many seconds does it take to get to the ground? So graph it in Desmos and see where the x-intercept is. Pause the video in 1, 2, 3. Alright, so here's the screenshot of my Desmos. And you can change your window, you can zoom in and out, but it looks like it takes 2.062 seconds to reach the ground. So the hardest part about modeling is figuring out what they're asking. So if you'll notice, what I'm doing is I'm labeling what the x and y are. When I'm reading the sentence, I'm labeling what they're giving me and what I'm looking for. That's what I would suggest that you do also. But it's a free country, you don't have to. Alright, so number 2, Braden jumped off a cliff. He's okay, he's fine. He hit the water, so he's good. Here's our little formula. I want you to pause the video and I want you to find the equation of the curve and best fit in 1, 2, 3. So I got negative 16x squared plus 18x plus 480. So let's talk about what the variable is representing. X is talking about time, and y is talking about height. And usually it doesn't change. That's pretty much what it always is. Remember we talked about how negative 16 is the gravitational constant. That's why that negative 16 keeps popping up. The thing that I want to try to find, how long will it take? So that's talking about time. So what is the x for the y to be 150 feet? Okay, so I'm going to take 150 and I'm going to replace it right here. So once you know what y actually equals, you don't need y, you can just replace it with a number. Same thing goes for x. If you knew what x equaled, then you replace x. Okay, so this is just a quadratic. Quadratics always need to equal 0, so I need to move that 150 over here. So my quadratic is actually going to be negative 16x squared plus 18x plus 330. So now you need to solve this quadratic. You can solve it by graphing it. I think it's super easy to do it that way. You can solve it by factoring. I would not recommend. And you can solve it by the quadratic formula if you like to torture yourself. I'm going to solve it by graphing. You can do whatever. Pause the video and solve it in 1, 2, 3. Okay, so I had to zoom out a little bit so I could see it, but you can see the entire parabola. So x equals 6.069. So just making sure you can read the question and that you can interpret what it's looking for, and then you're using all the stuff we talked about in the quadratic. So it gets a little overwhelming, I know. Take a deep breath, you're going to be fine. Okay, take a deep breath right now. Woosah. This one's kind of tricky. So I want you to pause the video and I want you to read the question before we talk about it. So pause the video in 1, 2, 3. Okay. So we have 2 towers. They are 800 feet apart. They are 162 feet high off the road. suppose that the cable between the two towers has the shape of a parabola, which we see in our picture, and it's 2 feet higher than the road at the point halfway between the two towers. So what I want you to do is I want you to think about putting this on an XY coordinate. So if this was your x-axis and this was your y. In order to come up with a quadratic equation, you have to have at least 3 points. And the 3 points that we have are right here in blue, here in red, and here in green. We actually do have enough information in this problem to come up with coordinate points. So here's what we're doing. We're thinking about this quadratic, and we're trying to come up with what these points actually are. And then we're going to use those points to come up with a quadratic function. Okay, so the blue point. If we were right here and we're directly on the y-axis, we would definitely be at 0. And we know that we're 162 feet in the air. So that point is going to be 0, 162. Alright, now let's do the green point. The green point, to get to that, we have to go 800 feet over, but we're still at the same height of 162. So that point would be 800, 162. The red point, that is directly in the middle between 0 and 800. What would the x-coordinate be that's directly in the middle of 0 to 800? It would be 400. That's half of 800. And it says that right there in the middle, it's 2 feet high. So it's actually stating exactly the coordinate points. You just have to read and interpret it. So here's what I'm going to do. I'm going to make us a little table. So x and y. So I have an x-coordinate of 0, a y-coordinate of 162. I have an x-coordinate of 400, a y-coordinate of 2, an x-coordinate of 800, a y-coordinate of 162. I want you to take this data and I want you to come up with a curve of best fit, just like we have been in the previous problems. So pause the video and come up with the curve in 1, 2, 3. Okay, so I rounded just to make my life easier, and here's what we got. So we used the picture and the information in the problem to come up with 3 points, and then we used our 3 points and put them in a table, and then we used our table to come up with a quadratic function. I know that's a lot, but now we can actually answer the question. What is the approximate height, so y is height, of the cable 120 feet from either tower? So now that I know x is 120, I'm going to replace all the x's with 120, and I'm going to come up with my answer. Alright, so do this in your calculator and pause the video and actually try it in 1, 2, 3. So I found that the answer was approximately 80.877-ish. If you round it a little bit differently, that's fine. We should get pretty close to 80, 81. Alright, and if you look at answer choice A, you have 80, so answer choice A is the correct one. Okay, now take a deep breath because we're through with that one. Lord. Okay, so now I want you to read this one, and notice that these are release EOC questions. So I didn't just make these up. They've been on the actual final exam before. So go ahead and read this one entirely in 1, 2, 3. Okay, so I think this problem is, it's easily done incorrectly if you don't read it. So it definitely says the height of 2 different projectiles after they are launched is modeled by f of x and g of x. So I'm going to do 2 different colors so you realize that you're talking about 2 different functions, 2 different graphs. So f of x is up here, already given to you. That's nice. You need to graph that and find where the maximum height is. Look at the y-coordinate because y represents height. And then in blue, we have this table. So obviously we don't have a function yet. So we're going to have to take the blue one and we're going to find a quadratic model. So I want you to pause the video, and I want you to find what g of x is. 1, 2, 3. Okay, so when you do this, you should get negative 16x squared plus 40x plus 9. Okay, so you need to do 2 different graphs and 2 different vertexes and look at 2 different y coordinates. So the red one, f of x, and the blue one, g of x. So pause the video again and graph those in Desmos or whatever you use and find the y coordinate of the vertex because y represents height. 1, 2, 3. Okay, so after graphing them in Desmos and coming up with the y coordinates of the vertexes, I got 39.563 and 34. And then the question asks, what is the approximate difference? Remember, difference always means subtract in the maximum heights. So I'm just going to do 39.563 minus 34. And you get 5.563, which you can round to 5.6. So that is your answer. That one's, it's not hard as long as you're reading and understand that you're talking about 2 different ones and that you need to subtract. Okay, go ahead and read this one. Alright, the dimensions of a square are altered so that 8 inches is added to one side while 3 inches is subtracted from the other. The area of the resulting rectangle is 126. What was the original side length of the square? So you started out with an x by an x because that's what a square is. And 8, I can't read, was added to one side and 3 was subtracted from another. And remember that area is length times width, and it tells us that the area is now 126, and we already know that the length is x plus 8, and the width is x minus 3. So all you got to do is graph this, and you could graph it just like it is in Desmos, or you could simplify it and graph it. Either way is fine, but do something and try this and figure out what x is in 1, 2, 3. Alright, so x equals 10, so that was the original side length. And then you could plug it back in to make sure it actually works, but just to save time, it works. Okay, moving on. Okay, so a juggler tosses a ball into the air. The ball's height h and time t can be represented by this equation. Sorry, this program doesn't have like a really good formatting, so that's why I have to write in the equation sometimes. Okay, so here's the equation. We're going to find the maximum height of the ball and the time it took to reach the ground. So that is 2 different things we're looking for. Also remember that x is going to be time, like always. Y is going to be height. So when we want to find the maximum height, you need to find the y coordinate of the vertex, and when we want to find where it reaches the ground, that is the x-intercept, the place it hits the x-axis. So go ahead and graph this and find both of those, and pause the video and do it in 1, 2, 3. Alright, so the maximum height it reaches is 29, and then the time it takes to reach the ground is 2.596. So all you gotta know is how to find this stuff, how to interpret it, what you're looking at. Okay, so this one is kind of weird, but notice that there are 4 terms. 1, 2, 3, 4. And usually quadratics are already in 3 terms, but anytime there's 4 terms, what I want you to do is I want you to just assume... Okay, sorry, I had to do that again because I was running out of room. Okay, so you have 4 terms, and anytime you do that, just assume that they've already been like kind of broken apart. And so all you gotta do is group the first 2 and the last 2, and then pull out GCFs. So if you look at that first one, they have a GCF of 7m, and remember when you take out the GCF, it's going like you're dividing, so it's going to be m plus 2. The second one's a little harder. It's a negative, and they both have a t, so m plus 2. And then notice that they both have the m plus 2. And then the 2 GCFs that you took out were 7m minus t. Now you're not going to see both of those, but you'll see one of them. So m plus 2 is definitely on the answer choice. So C is my answer. Okay, so here's another one that's been on the released EOC before. The graph of x squared. So you know that graph looks like this. It has a vertex at 0, 0. It is translated 5 units up and 2 to the right. So if you think about that point 0, 0 going up 5 and 2 to the right, it would now be at 2, 5. So which of these functions has a vertex at 2, 5? So pause the video, graph them all, and see which one has an actual vertex at 2, 5. And it's pretty easy because it's the first one. So then you're done. All right, moving on. So this one asks, which equation has exactly one real solution? So which one only hits the x-axis one time? That was a horrible picture. Don't judge me. So pause the video and graph all of them, and which one hits the x-axis only one time. So pause the video in 1, 2, 3. And so B is the only one that when you graph it, it only hits one time, so it only has one real solution. Alright, so I know that was a lot, but now you've gotten to see like what the actual final exam problems are, and hopefully it helped. Maybe you're still confused. Go do your haiku assignment, ask me for help. I will see you later. Bye.